Hi, my name is Sohan, and I'm an incoming sophomore at Xavier High School. And my main project is the gesture-controlled car with accelerometer. So, just a reason why I chose this project is just because one thing I always like is hands-on projects. And one thing I want to get out of Bluestamp is learn a little bit about basic code commands and a little bit about coding. So I thought this was the best of both worlds because I was able to create a car as well as learn how to code the car. So here's a demonstration of my final product. Okay, so let me just play this. So as you can see, the car is going forward, and this is due to my hand moving forward. And as it moves back, it's because my hand's moving back. And as the robot turns, this is due to my hand moving right and left. And all of this is happening due to a component called the accelerometer. So basically, the accelerometer is creating these values, which the receiver uses to make the car do all these cool things and move right, left, forward, and backwards. So in my project, there are three main components which all work together to create my project, and they all have specific roles. So the first that I used is the something called the motor driver. And the motor driver is really important for the proper function and consistent function of the motors on my car. So what the motor driver does is that it converts low current to a high current. So basically the Arduino, which is a microcontroller, produces a low current. And this is not good for the motors because it doesn't allow them to run consistently. But the motor driver actually converts this low current into a high current. So acts as an interface between the Arduino and the motors. So that was a very important piece in my project. So the next important piece in my project is something called an accelerometer. So what an accelerometer does is it creates values based on, I guess, its movement. So for example, if I tilted the accelerometer to the right, it may produce a 5. And if I tilt it to the left, it may produce, like, say, a -5. And these values can be used through code to make the motors turn certain ways and do certain things. So one main issue I had with the accelerometer is that it didn't work consistently. And we found out the problem was that the pins were sometimes very loose. So we had to do is we had to solder wires directly to these pins. And this was not easy at all because the pins were so close to each other that just trying to get the soldering out of there was a challenge. But like after doing this many times and like having to unsolder things and resolder things, I was able to get this done, and it definitely proved to work more consistently, and it definitely paid off. So the third and final main component of my project are called NRF modules. So these are basically wireless communication pieces that send and receive data. And this is what made my project happen, because with the accelerometers creating the values, then the transmitter processing these values, then the NRF modules send data to tell the motors what to do. So basically, the NRF modules were not easy to use at all because setting up the initial connection between them is not very easy. It just takes a while. So it took me about 3 days just to get them to be able to connect to each other and say a simple message, "Hello world." But after this, they became a lot easier to use because after establishing this initial connection, they're able to connect to each other when I turn them on fairly easy every time. So all these parts work together, like I said, in a circuit to make the car work. So for example, the motor driver makes the motors run, the accelerometer creates the values which tell the motor what to do, and the NRF modules, most importantly, transmit the data wirelessly. So it's not like, so I have a wireless communication set up between them. So the modification I made to my robot, and you probably saw in the video, is that there are a strip of neopixels on it. And what I did is that these were not just any random set of lights. So basically what these neopixels did is I programmed it to turn different colors based on the direction the robot is moving at that point. For example, if the robot's moving backwards, the car would light up red. So being a student at Bluestamp has been a great experience because it's taught me about trial and error and patience. So for example, like I was mentioning earlier, those NRF modules took me a while just to get to work. But with patience, I took my time. I just kept on re-downloading code, changing things using different code files, and it worked. It paid off and it worked. Because as long as you put in the effort, Bluestem has taught me that you will be successful. And when you have drive and passion for something, you'll always be successful. So one other thing with the patience part of this is that because I was patient and didn't rush through this whole project, I was able to learn what each component does specifically. And this was great because it's knowledge I have for the future on future projects I may do with Bluestamp or in the future. So I definitely learned a lot of skills here about engineering, but also just life skills that I can use throughout my life. Thank you for listening.
Great job, Sohan. Does anyone have any questions?
I just want to ask Sohan if he would be willing to present his robot at the League of Computer Scientists meeting when we start back in the fall.
Sure, I would love to. I definitely learned so much here at Bluestamp that I can definitely display, give a good presentation about all the different components on the car.
Cool, you're on the roster.
Okay,
Amazing.
great.